Mathematica and the Raspberry Pi. The raised cosine channel. There are many variations of the raised cosine channel. If the bandwidth is limited to 1 and the roll-off factor is 0, it resembles a brick wall filter, and the impulse response is a sync pulse. When the frequency response is normalized to 1, the zero crossings on the time domain response occur at multiples of 0.5. If we increase the roll-off while keeping it symmetrical around a frequency of 1, we notice that the zero crossing interval of the sync pulse remains the same. However, the sync pulse tails are dramatically reduced. Setting the bandwidth or vestigial symmetry to 0.5 causes the time domain response to have zero crossings at multiples of 1. As expected, increasing the roll-off dramatically reduces the tail of the sync pulse. Modeling the raised cosine channel in Mathematica is relatively straightforward. Clearing all of the variables. We start by calling up the manipulate function and then defining the raised cosine curve, pulse, and channel. We create a graphics row and we plot the raised cosine channel on the left and the raised cosine pulse on the right. Plot the raised cosine channel. Plot the raised cosine pulse. Define the manipulate variables and label the frame. We can now run the program and observe what happens to both the frequency and time response of the raised cosine channel as we vary the roll-off rate as well as the bandwidth or vestigial symmetry.